Good afternoon, good evening, whenever you might be listening to me at any part of the world. Okay, this is Coach Atoba Olushola, your physics, further mathematics online. Once more, this is the second part 2 of kinematics. We have been dealing with this topic since last lesson. Last lesson, we derived 4 equations of motion, but it has not been applied. It has not been applied. So, whenever you are watching me from any part of the world, you can visit my YouTube channel, 0 to Pro 7. Yes, 0 to Pro 7, that is my at 0 to Pro 7. You might visit my YouTube channel, okay? Or you can visit my Facebook, or you can visit me on Instagram, okay? You should always know that ability is of little account without opportunity. Okay, now let's move on. These are the questions we want to solve today. These are the questions we want to solve today. You can see the question 1, see question 2, see question 3, see question 4. Okay, and when you view, see question 5. Okay, see question 5. Okay, and 5A and 5 Roman figure 1, 5 Roman figure 2. Now, I want us to pump into action. Okay, I want us to pump into action as we start what? We start solving those questions. As we start solving those questions. Okay? As we start solving those questions. Okay? Now, I don't want to want the question to go from your view. Yes, I don't want the question to go from your view. Yes, I want the questions to be here. And yet, as we are solving the question, you are reading them comprehensively, and we are solving them here. And we are solving them here. That is my essence of solving them for you. Okay? Now, okay, this is a part of the board. This is another part of the board. Now let's start. Solutions. Now a ball starts from rest. When anything starts from rest, initial velocity is what? 0. U from rest, that's question 1. Okay? From rest, U is what? 0. Okay? Acceleration is already 8 meters per second square. Acceleration is already 8 meters per second square. The time taken is what? Is 4 seconds. Okay? We have to look for the final velocity reached and the total distance covered. Final velocity reached is V, is unknown. Total distance covered S is unknown. If you look at this very well now, you will see that the 5 ingredients of motion, U, A, T, B, X, is already completed here. But we need to really find it. This is a particular rectilinear motion, it's an accelerating motion. Now, using V is equal to U plus AT to find your V first. What's your V? We don't know. Now, your V is equal to U is 0. Acceleration is what? 8. T is what? 4. V is equal to what? 32 meters per what? Second. 32 meters per second. Also, okay? Also, looking at your S, getting your S, using your S is equal to V plus U over 2 into T. Okay? Into T. Oh yeah, your S is what? What's your V? 32. What's your U? 0. Over what? 2. Your T, time taken is what? 4 seconds. You need to learn how to cut. It is not good to use calculator, most especially you that want to do jam. Calculator is not your portion. Calculator reduces the brain efficiency. Calculator does not allow you to think straight. So you should be able to calculate without calculator, especially when you are for JAMB, when you are for SSE, or you are an A-level student. Okay? Let's move on now. This is 32 over 2 times 4. 2 here 1. 2 in 4, 2. 32 times 2 is what? 64. 64 meters. You can see question 1 has been answered. It is what? 64 meters. It has been what? Answered. It is 64 meters. Okay? Now, we are moving to question 2. Question 2. A car accelerates at 6 meters per second square for 10 seconds. A car accelerates at 6 meters per second square for 10 seconds before coming to rest in the next 4 seconds. Calculate the deceleration and the total distance covered. Okay? In the question 2, this is a question of both acceleration and deceleration all together at the same time. It's a question of acceleration and deceleration together at the same time. So let's look at it at acceleration. At acceleration, a car accelerates at 6 meters per second square. When it accelerates, it's from rest. It's from rest. So when it is from rest, what do we have? Your u is what? 0. Then, what do we have? 6 meters per second square. A is 6 meters per second square. Okay? For 10 seconds. Time is what? 10 seconds. Time is what? 10 seconds. Okay? Now, I told you, in any rectilinear motion, the 5 ingredients of motion must be sought for. U, V, A, T, S, the 5 must be sought for before anything at all. The 5 ingredients of motion must be sought for at any rectilinear motion before visiting any other form of motion. This is what? Is accelerating motion. So you visit the 5 first. U, A, T, V, we don't know it in meter per second. We don't know it. It is hidden. We don't know it. S, we don't know it. At what? S in meter. We don't know it. At acceleration. These 2 parameters needs to be found first. When you found these 2 parameters, you can now visit decelerating motion later. Okay? Now, in this case now, get it again. Using what? Using V is equal to U plus AT. Your V is V. U is 0. A is 6 times 10. Your V is 60 meters per second. Also, now for S, using S is equal to V plus U over 2 into T. Simple equation of displacement. Now, come around your S, V. V is 60 plus 0 over 2 into T. Your T is 10. Okay, this is 60 over 2 times 10. 2 here 1. 2 here what? 5. 60 times 5 is what? 300 meters. 300 meters. Hence, let's look at it at deceleration. At deceleration to rest. At deceleration to rest, we know it comes to rest. When it comes to rest, final velocity V is what? 0. Initial velocity is the velocity it reached before matching the brake. So the initial velocity becomes what? 60 meters per second. Okay? Initial velocity is 60. The time taken to come to rest is what? 4 seconds. Where T is what? 4 seconds. Where T is going to 4 what? Seconds. Okay? where t is what? Is 4 seconds. Okay? Looking at that now, using what? I told you before that your v, your u, your t, your s, your v should be what? Completed in any form of motion. Look at the decelerating motion. We have v, we have u, we have t. No s. No s and no a. And look at the question here. See what they say concerning the question. Calculate the deceleration and the total distance traveled. Calculate the deceleration and the total distance traveled. Definitely the deceleration, looking at the deceleration, your deceleration A is minus A meter per second square. It is negative. Total distance covered, we want to see distance at what? At deceleration. But don't forget, the total distance covered will be total distance at acceleration and at deceleration. If we call this S1 and we call this S2, which is unknown, then total distance covered would have been what? The summation of F1, S1 and what? S2. Let's move on. In this case now, what do we have? In this case now, what do we have here? Using what? Still using V. Yes, using V is equal to U plus what? Plus AT. Using V is equal to U plus what? AT. Okay? What is your V? Your V is 60. Your V is 0, not 60. Your V is 0. You see? V is 0 is equal to U plus AT. U is 60. Okay? Our acceleration is minus A. Your T is what? Is 4. So, talking about this now, what do we have now? Okay? What do we have now? We have 0 is equal to 60 minus 4A. Bring the 4A is what? 60. What's the magnitude of the acceleration? The magnitude, okay? The magnitude of the deceleration A is what? Is 60 over 4. 60 over 4. That is when you divide both sides by what? By 4. So the 4 here 1. 4 here is what? 15. So that it becomes 15 meter per second square. Okay? It becomes 15 meter per second square. Now we are to find the second displacement. The second displacement at what? Deceleration. Hence, S2 is TV plus U over 2 into what? Into T. This time around, your final velocity is 0. U is 60 over 2. What is your T? Your T is 4 seconds. Your T is 4 seconds. This is 60 over 2 times 4. 2 here 1, 2 here 2. This is what now? 120 meter. S2. Okay? Remember, we have answered the first question, which is the what? Which is the deceleration. The magnitude of the deceleration is 15 meter per second square. Now, it remains the what? The total displacement. The total displacement. Hence, S total. S total. Total displacement, S total. It will be what? S1 plus what? S2. S1 plus what? S2. So what do we have? What is S1? Your S1 here is 300 meter. It's 300 meter. Plus S2, 120. Making what? 420 meter. Making 420 meter. So that is the what? That is the second question. Now let's move to the third question. Okay? Moving to the third question. Moving to the third question. Okay? Moving to the third question. Look at the third question here as we read the third question. Okay? The third question. Two particles, A and B. Two particles, A and B, starting from rest, such that A covered a distance quadruple that of B as its acceleration is twice that of B. Find the ratio of the time taken by A to the time taken by B. Okay, I've told you, you might not be able to watch this lesson completely. Visit my YouTube channel at 02Pro7. Visit my YouTube channel at 02Pro7 to complete your lesson. Okay, now let's go. Now, we go to question what? Question 3. Question 3 now, as we move. To question 3. Okay? Two particles, A and B, starting from rest. Two particles, A and B, starting from rest. What do we say? This is particle A. Okay, this is particle B. As they are starting from rest, what does it mean? It means they have initial velocities that are 0. Both of them start from rest. So U of A is 0. While U of B is what? Is 0. Are we there now? U of A is 0. Yes. U of B is also what? It's also 0. Okay, now it starts from rest so that A covers the distance quadruple that of what? Of B. If A covers a distance quadruple that of B, S of A is 4S of B. Quadruples means what? 4 times. Quadruples means what? 4 times. Triple means what? 3 times. Double means what? 2 times. So don't forget this. Don't make any mistake. A lot of misconceptions are concerning this. Okay? Now, S of A is 4S of B. Okay? Now, as its acceleration, look at it, as its acceleration is twice that of B. It means the acceleration of A is twice that of B. A of A is 2A of B. That is what we discovered. A of A is 2A of B. Isn't it? Now, what are we looking for? Find the ratio of the time taken by A to the time taken by what? By B. Find the ratio of the time taken by A to the time taken by what? By B. Now, what are we looking for? TA ratio what? Ratio TB. We are looking for TA ratio what? TB, which is automatically what? TA over what? Over TB. That is what we are looking for. Okay? Now, looking at this very well, when you look at it very well, you will now look at it that we are giving S, we are giving A, we are giving T. Okay? Among all the equation of motion, the most suitable is S. Using S is equal to UT plus half AT squared. Using S is equal to what? UT plus half AT squared. That is what we are going to use. Okay? Now, looking at this very well now, you should know that initial velocity is what? 0. Initial velocity for both A and B are what? Are 0. Okay?